Hello, welcome to this video with a new audio. Please tell me if you can hear that the audio is any better than normal because I'm using a brand new microphone. All right, so this one is from Hlompo. It's a buffer one. Looks nasty, but it's actually not so bad. Buffer solution is to be made using 1 molar ethanoic acid and 1 molar sodium ethanoate. We've got to calculate to the nearest cc the volumes of each solution that would be required to make 100 cc of a buffer solution with 5.5 pH. Please show all steps in your working, and it gives us the Ka value. So the way I like to start these things is, first of all, getting a pen that works. All right, first of all, I'm going to write down the equation for the dissociation of ethanoic acid, okay, which dissociates into the ethanoate ion plus the hydrogen ion. That's, honestly, doing that is important. To me, it is anyway. Now I'm going to get a different color pen, and using this equation, I'm going to say the Ka is equal to the concentration of the base form, or the salt form, times the hydrogen ion concentration, all divided by the concentration of the molecular acid. Okay. Now, what have we got? Well, we've got quite a few of these things. We've got the Ka and we've got the pH. All right, so we've got the hydrogen ion concentration. What we don't have is this, the concentration of the base form and the concentration of the acid form. Well, we do have the concentration. They're both 1, okay? But we're not going to use those ones. Well, we're going to use the fact that they're both 1 for something quite interesting. So first of all, let me put these over the other side. Let me say Ka is divided by the hydrogen ion concentration is equal to the base concentration minus, divided by the molecular acid concentration. Now we're going to use a trick. Well, it's not a trick. It's this fact. We don't know what the concentration of this is. Well, we do. It's 1 molar, and the concentration of the other stuff is 1 molar. So because the concentration is equal to number of moles over volume, or N equals CV, we can divide one property, the one volume, by the other, because the volume will be proportional to the concentration. Okay, so what we can do here is we can say the volume of the base form X divided by the volume of the acid form. Now, because we know the two volumes add up to 100 because of this bit here, we can say 100 minus X here. So it's a mathematical trick rather than a chemical trick here. All right, so let me put this over here, nice different color. All right, so Ka is 1.79 times 10 to the minus 5 using this here, divided by 10 to the power of minus 5.5. That's the concentration of the hydrogen ion, is equal to X divided by 100 minus X. Okay, now I'm going to use the calculator. 1.79 exponential minus 5 divided by 10 to the power of minus 5.5, and that gives me 5.66, I think. Yeah, so that's going to give me, which is a strange number, 5.66 is equal to X over 100 minus X. Let's flush this out. So we have 566 minus 5.66. X equals X. Solve for X, so we get 6.66X equals 5. Oops, that's wrong. Is equal to 566. So therefore X is equal to 566. Struggling with the calculator again. The batteries have gone. 566. 500 divided by 6.66. And that gives me 84.98. Okay, so 84.58 is 85 centimeters cubed. So that's centimeters cubed. So the volume of this one, the base form, which is this one, is 85 centimeters cubed, and therefore the volume of the acid must be 15 centimeters cubed because it's 100 minus X, isn't it? All right, hope that helps. If it doesn't, give me a shout. But to be honest with you, this relied, as I say, more on a mathematical trick, this thing, which came from the fact that the volume of one thing plus the volume of the other thing must equal 100. So you can say X and 100 minus x, can't you? As I say, this is a maths trick more than a chemistry trick. And from that, I can tell this is quite an old paper. Okay, now they tend not to do these nasty things anymore, but you never know. It's always good you know these things. So it's a problem-solving maths trick more than chemistry. All right, thank you very much. Let me post this now.